Welcome. How you doing? We are now for this on to the sixth assignment for Khan Academy this week. We're going to be taking a look at this assignment called multi-step linear inequalities. And the kind of exciting thing about this is actually a ninth grade assignment, so this is something you may be seeing next year. But if you've worked up to this far through two-step inequalities and the equation solving we did this year, you're ready to do this ninth grade assignment called multi-step linear inequalities. So it's going to be very similar to the two-step inequalities. The difference here now, of course, they're going to be more complicated equations that make you do more work. If you recall, a lot of the tougher equations we solved this year had the variables show up in more than one term, often on both sides of the equation. And what's tougher about these inequalities, these multi-step linear inequalities, is we're going to see a lot of them have the y or the x, whatever the variable is, showing up on both sides of the inequality. And that's what we see here. We're asked to solve this inequality for y and reduce any fractions to the lowest terms. So I'm going to take a look at this first inequality. It's definitely more complicated now. I'm going to put it on my whiteboard. It says 5y plus 3 needs to be greater in value than negative 7y plus 13. And I'm going to go ahead and draw the river a line straight through that inequality sign, much like we did when we were solving our equations when the variable was on both sides. And if you recall, the key, when we have a variable term on both sides of an equation or an inequality, we can't really solve it until we gather those variable terms to the same side of the equation so they can be combined. Here, I could either try to move the 5y away from the left side of the equation and send it over to the right expression, and that would be with a negative 5y. Or even easier, I could move the negative 7y by using a positive 7y. So that's the choice I'm going to make. I like positive numbers, so instead of using a negative 5y to move the 5y to the right, I chose to use a positive 7y, which will cancel out the negative 7y and gather all of my y terms to the left side of this inequality. So by adding 7y to both sides of the inequality, I cancel out the negative 7y's on the right side, and all the y's are in the left expression now. 5y plus 7y gives us 12y. So we get 12y plus 3 needs to be greater than 13. Now this looks similar to the two-step inequalities we did on the last assignment. I'm going to subtract 3 because now that the y's are on the left side, I don't want the regular constants, the regular numbers on the left side anymore, so subtracting 3 gets rid of the positive 3. By subtracting 3, I've sent all my constants to the right expression, the right side of this inequality. 13 minus 3 combines to make 10. So now I have 12 times y needs to be greater than 10. I want to solve for y, so I'm going to divide by 12. That's the opposite of multiplying y by 12. By doing divide by 12, I cancel out the coefficient and I have just y. So I have 10 divided by 12. 10 does not get divided evenly by 12, but if they're both even numbers, 10 over 12 can simplify, divide them both by 2, to 5 over 6. So 5/6 is the same fraction simplified as 10 over 12. And as we're going to see here when I put this answer in now, they asked us to reduce any fractions to the lowest term. So that's what I was doing there at the end. I took 10/12, I reduced it to 5/6. So that's going to be our ultimate answer here. Y needs to be greater in value than the fraction 5 over 6. We'll do a couple more examples together. I'm going to encourage you at this point now, for the last few examples we do, for each one of these, pause the video, try to do it on your own. And if you think you're good doing these on your own, jump into Khan Academy and you can kind of stop the video at this point. So the next inequality, let's make that whiteboard a little larger so it's easier to read. The next inequality says negative 7p, negative 7 multiplied with p, minus 4, needs to be greater in value than 26 times p minus 94. I'll draw my line, my river through the inequality again. And I would encourage you, before you're watching me do this problem, try solving this on your own. For me, I see the p terms. There's p term in two different terms, and they're not on the same side of the equation, so I want to gather these p's on the same side of the river or the same expression. I like to move the smaller term always. If I have to pick one to move, it's easier to move the negative 7p by adding 7p than it is for my brain to subtract the 26p. So for that reason, I chose to add 7p on both sides. That cancels out the negative 7p. So negative 4 is all that remains in the left expression, and that needs to be greater. 26 plus 7 gives us 33. So 33p minus 94 is what the right side simplifies to make. Now that the p's are gathered on the right side, I don't want the constant, the negative 94, on the right expression. So I'm going to gather that to the left side by adding 94. That cancels out the negative 94 that I did not want on the right side of the equation. Shows up over here as a positive 94. 94 minus 4 gives us 90. So now we have 33 times p, and that needs to be less than 90. I'm going to divide both sides of the equation by the coefficient. I want to get rid of the multiply by 33, so I divide by 33. And now I get p is equal to 90 divided by 33. If I go ahead and put, oh, I messed up there, my fault. This is an inequality, so this inequality sign comes down. We didn't divide by a negative number, so that's still going to say 90 over 33 is greater than p. So I'm going to put that in here. They ask us 90 over 33, the fraction, needs to be greater than, make sure that greater than symbol isn't in there, greater than p. And I'm going to check. And I'm told not quite yet. It says try again, get help, or skip for now. So I'm going to go ahead and get into the get help. I thought the answer was 90 over 33 is greater than p. I look through their work, and I see they had 90 divided by 33, but then they simplified to 30 over 11. So I'm going to look to my whiteboard, and wait, they had 90 is greater than 33 times p, just like we had here. But then they didn't do 90 over 33, they put the answer in as 30 over 11. And what I need to recognize is 90 over 33, because 3 can go into both 90 and 33, this could be simplified for this fraction. If I divide them both by 3, I get 30 over 11. So that's how they recognize 90 over 33 needed to be simplified to 30 over 11. So now I'm going to fix my answer, which was basically correct, but not reduced yet, so that's the reason Khan Academy marked it wrong. 30 over 11 is the same value as 90 over 33, but the simplified or reduced form. We're going to look at one more example, and yes, as you've noticed, these are tough assignments. Like we said, it's a 9th grade assignment, so they throw plenty of fractions and lots of steps at you. So one more example here. Again, if you're still watching, I would encourage you to be doing this example on your own before you watch me by pausing the video. It says 54x plus 64 needs to be greater than or equal to 49x plus 59. Here, pause the video, try to do it on your own. As you're coming back, I see that the 54x and the 49x are not on the same side of the equation, and I want to gather them to the same side. I prefer to move the smaller number or the smaller coefficient always. That tends to lead towards positive numbers, so instead of doing negative 54x, I'm going to choose to do negative 49x. And that's going to cancel out the x's that are on the right side of this inequality. I need to subtract 49x on both sides of the inequality to keep it true. So 54 minus 49 gives me 5x plus 64. Has to be greater than or equal to 59. Now that the x's are all on the left side of this inequality, I want to get rid of the positive 64. I use a negative 64. That's the opposite of adding. And that will cancel out the positive 64. So that gives me 5x, still going to be greater than or equal to 59 minus 64. That gives me negative 5. This is a lot like 64 minus 59, except it's opposite version. 5x is greater than or equal to negative 5. The opposite of multiplying by 5 is to divide both sides by 5. That cancels out the coefficient. Now I have x is greater than or equal to, I divided by a positive number so that inequality will not flip. Negative divided by a positive makes a negative, and any number divided by itself makes 1. So that's how I find x is greater than or equal to negative 1. We're not going to show this last example. If you're working on your own and you're struggling with this tough 9th grade assignment, I would encourage you, as always, to watch Sal Khan's videos, hit the Get Help button and read their explanations for assignment questions that you miss, and definitely feel free to email me. I would be more than happy to jump in with you on Google Meet and provide some one-on-one help for this tough 9th grade assignment. Thank you for watching to the end. Keep up the great work.